The Sun is going through a turbulent phase, and scientists are trying to understand what might happen if its magnetic field were to reverse polarity. Such a phenomenon could pose a serious threat to Earth. At the moment, we are in the midst of a solar cycle that could culminate in a magnetic storm similar to the Carrington event of 1859. But what are the real risks to our civilization? And when might this potential megastorm hit us? Within the Sun, massive convection currents generate a magnetic field that directs streams of solar particles toward Earth, affecting our climate and technology. These streams, known as solar winds, can be both beneficial and dangerous. On the one hand, they warm the Earth, allowing life and vegetation to thrive. On the other hand, they can unleash devastating solar storms. In the 19th century, a solar storm paralyzed the young electric grid for days. Since then, much has changed. Today, our civilization depends on electricity almost entirely. A high-intensity solar storm could have catastrophic effects. Imagine waking up with the refrigerator off, the coffee machine not working, the sky lit up by colorful lights, while all means of communication are down. It's no surprise that many are worried. Scientists are monitoring the Sun 24/7, and concerning anomalies have emerged in recent days. The greatest fear concerns a possible flip or massive collapse of the solar magnetic field. But what is really happening inside the Sun? To better understand the situation, we must go back 4.5 billion years, when a cloud of cosmic gas and dust gave birth to our Sun. How is it possible that a giant ball of fire was born from simple particles of gas and dust? This remains one of the great mysteries of science. We know that, thanks to processes still not fully understood, the movement of these particles accelerated to the point of generating enormous pressures, fusing hydrogen and helium atoms. This process released incredible amounts of heat, and the Sun began to shine like a gigantic power plant, a process that continues to this day. The solar magnetic field is the result of complex electrical and magnetic processes within the Sun, a marvel of nature that coordinates a multitude of elements and metals in perfectly orchestrated chemical and physical reactions. But this perfection can also pose a threat. The solar magnetic currents, dynamic and turbulent, can trigger plasma ejections that bombard Earth with charged particles. Although Earth can protect itself from these storms, our electrical systems, satellites, and communication networks are vulnerable. A power outage could cause chaos. Planes would lose orientation, hospitals would be without power, and ATMs would stop working. Understanding solar cycles is crucial, especially since we are currently in a cycle that could lead to an event similar to the 1859 storm. The Carrington event went down in history for knocking out telegraph stations worldwide, generating fear and confusion. At the time, auroras visible in unusual locations and sparks flying from electrical equipment were interpreted by some as signs of divine punishment. Today, a similar event would damage our communications and power grids on a global scale. Although scientists are confident they can predict such events, the Sun has proven to be less predictable than we thought. In the spring of 2024, an unusual sunspot triggered storms so violent that they left experts puzzled. If this is just the beginning, what does the future hold for us? We must accept the possibility that a solar storm could hit us at any time, paralyzing our systems. For example, in 2003, a Halloween storm was detected only minutes before it struck. Plasma ejections from the Sun can reach Earth in just a few hours, testing our response capabilities. Although jumps in the Sun's magnetic field are normal, many doubts remain about how prepared we really are to face a devastating solar storm. Researchers reassure us that major solar events will be preceded by visible sunspots, but time will tell if we can truly trust these predictions. Thanks for watching, subscribe to the channel, and hit the bell to stay updated.